we can get started now. So, hello everyone. Hope you all are having fun at Cisco Live so far. All right. So we are truly excited to welcoming you to the third edition of Introduction to Catalyst 9800 Wireless LAN Controller session. My name is Shankar Ramanathan. I'm one of the technical leaders at Cisco Wireless Stack. I'm joined by my colleague sitting in the recording theater, Alejandro Ramirez Gomez. He would be my demo and Q&A assist today. So before I get into the agenda, I just wanted to give a little bit of background. This session used to be a 4-hour tectorial and a 2-hour breakout event at Cisco Live San Diego, and we have decided to make this content concise and deliver it in 60 minutes. So I'm going to try my best to do justice to some of the topics on why we need Catalyst 9800 controllers, and what are the key differentiators between Catalyst 9800 controllers and the all-famous AirOS controllers, and how do you, the users, migrate into the 9800 strategy in terms of understanding the newer configuration model, the migration tools, and the IRCM model that are available today. So having said that, this is a packed 60-minute session, so I'd love to have a live interactive session, question-answer session with you, but please keep your questions short. If you have a specific detail-oriented question, I'd recommend use the WebEx Teams, where Alex can answer the question in parallel, both in English and Spanish. So just a quick show of hands to understand my audience. How many in here are familiar with the AirOS brand of controllers, like your 2500s, 5500s, 3500s, virtual WLCs, Mobility Express? Okay, I see significant hands raised. So the reason why I polled this is I want to make sure that I want to understand how much time I need to spend explaining the newer configuration model differences between the AirOS controllers and the iOS XE controllers, so that you understand why we had to go into the newer configuration model. So let's start by answering the question why Cisco moved into the 9800 controller strategy. So to understand why, we put the obvious slide. So if you were in Cisco Live sessions today or yesterday or last year or the year before that, you would have seen Cisco consistently talk about a strategy called intent-based networking strategy. What is intent-based networking strategy? I like to keep it simple and keep things to wireless, so I'll explain this with an example. Let's say I want to put a guest wireless network for this room. So my intent is to create a guest wireless network for this room. So the part of absorbing my intent and translating that into configuration pieces across various network elements, let it be routers, switches, controllers, or ICE, belongs to the central brain system, the DNA center. So intent-based networking, in short, is basically converting your intent into configuration pieces and taking the context back from the network, and this loop basically completes what is the intent-based networking strategy. Okay, so when you have this intent-based networking strategy, wouldn't it be nice if all the network elements involved in this configuration steps actually have the same base operating system? And with that logic in mind, the Catalyst 9200, 9300, and 9400 access switches, along with the 9500 core or aggregation switches, came into fruition. And 9800 controllers came into fruition to complete the solution strategy from end-to-end base point. So access switches, core switches, and now the controllers all operate under a same iOS XE-based operating system to complement the intent-based networking. So for folks who raised your hands on familiarity with the AirOS brand of wireless LAN controllers, you know that Cisco is a market leader in enterprise wireless deployment, which means AirOS is the most deployed operating system out there today for wireless LAN controllers. So taking key elements like RF excellence, device ecosystem, and wireless assurance from AirOS and merging it with the modularity of what iOS XE provides in terms of programmability, scalability, high availability is what makes 9800 controllers truly unique. So in short, there are 3 key differentiating mantras that power the 9800 controller. It's the resilience, security, and intelligence. Resilience is one of my favorite features. especially coming from a tag background. I'm assuming the majority of you are network administrators, wireless network administrators. So what is one of your biggest challenge in wireless, right? Software upgrades are inevitable. And what typically happens in your software upgrade? You basically need to figure out a maintenance window, and maintenance window typically happens in middle of the night in production environments. And there is an upgrade cycle. You wait to upgrade your controller, you wait to upgrade your access points, and then the next day is the D-Day wherein you actually figure whether the purpose of the upgrade was solved when your clients come back in. So what 9800 offers is an ability to cover all these planned upgrade scenarios, whether you are trying to upgrade or patch the controller or access point, to provide zero network downtime to your clients. And we will see via demonstrations and via slides on how 9800 covers these planned upgrade scenarios and covers these bases so that end network, wireless network client does not go through an outage during these upgrade cycles. That's a true powerful feature of 9800, a resilient feature. Security is standard as part of IOSXE, the encrypted threat analytics, the automated micro and macro segmentation with SDA and WPA3 support, all standard of IOSXE. Then you come into intelligence. What makes 9800 intelligence? It's not only the ability to be managed by, for automation and assurance purposes via the Cisco DNA Center. It's not only the fact that this one single box is powerful, has powerful programmability and telemetry, that it deserves its own session. But the key intelligence aspect for the 9800 is the ability of that same base operating system to be deployed across multiple platforms. So you can deploy the same wireless LAN controller based on IOSXE, either as an appliance, 9880, 9840, or 9800L, or embedded inside a 9800 switch, or as a private cloud in a hypervisor appliance, or in a public cloud and Amazon Web Services, or embedded inside an access point, which is soon coming. So the same operating system is versatile enough to be deployed across appliances. And it's only the scale that limits you to choose what appliance you want. So you start as low as 100 APs to as high as 6,000 APs, and you have one solution from small, medium, or large campus. You can choose what you want on that same based experience on the IOSXE software. So let's understand from a solution standpoint. We support the Wave 1, Wave 2, and the latest Wi-Fi 6 access point. So by Wave 1, I mean the 1700s, 2700s, 3700s. Your Wave 2 would be the 1800s, 2800s, 3800s, and the latest 9100 series access points. All the modes of operation are supported on the 9800 platform, whether it's local, FlexConnect, Fabric, Mesh, Bridge. You choose the mode. It is available starting day 0. And on the 1611 release, which is the second release, it integrates with the DNA Center 1.3. So if you're the first release 1610, it would integrate with the 1.2.10 of the DNA. ICE, anything higher than 2.4. Prime infrastructure, anything 3.6 or higher, and CMX 10.6.1, and also the latest DNA spaces via the direct connect option or CMX tethered option. So this is like a solution overview. Let's have a closer look at the intelligence feature on how you can deploy this IOSXE on various appliances. So we'll start with appliances. So from an appliance standpoint, you can see 9840, 9880, and 9800L. So from an AirOS perspective, these appliances would equate to 9840. You can compare it with the 5520 controllers. 9880, you can compare it with the 8540 controllers. 9800L to your 3500 controllers. So without going into too much details, this is the 9880 is one of the true industrial controllers that offers the 100 gigabit Ethernet modular uplink, which basically means investment protection for future higher throughput needs, apart from the standard software advantages of resilience, intelligence, and security. So let's have a closer look at the 9880 appliance. So the equivalent for this would be 8540 when you compare it in the AirOS world. I'm not going to get into the numbers. You can always refer the data sheet or the slides for that. But if you notice the slide, on the top right corner, you see that modular uplink. That is the industry's first modular uplink controller. So that's the slot where you actually can upgrade the network infrastructure up to 100 gigabit Ethernet uplink. But look at anyone familiar with the 8540 or the 5520s, those are UCS-based boxes. You'd know that it occupies a huge amount of space in your lab. So this is about 30% smaller in terms of form factor, but packs a punch in terms of features. So 8540 to 9880, you would either see that the features are matched, if not greater than what 8540 used to offer, twice the amount of throughput. A quick note, if you look at the second bar, 6000 AP groups translates to policy tags, and FlexConnect groups translates to site tags. I would not worry about these terminologies for now because I'll explain it why AP groups became policy tags and Flex group became site tags in the newer configuration model section. So why we needed to move into the newer configuration model, that will start making sense on why we changed some of the terminologies here. Similarly, for the 9840, again, the equivalent is the 5520 controller. If you notice, it's 30% smaller, 9840, and is even smaller than the 5508 controller, which most of you may be familiar with. It's and again, from feature standpoint, like beats 5520 in almost every aspect, 500 access points more, 12,000 clients more, and from literal mapping matches, if not beats, features. Without going into too much details, basically a terrific upgrade from a 5520 controller. So that's for the appliance. Now let's understand how that same base operating system goes into the cloud strategy. So let's actually iron out some of the terminologies. When we refer to private cloud, in context to 9800, we mean the ability of that 9800 operating system to be installed in a hypervisor, namely your ESXi or KVM or NFVIS on ENCS. And by public cloud, we mean the ability of the 9800 OS to be installed inside the Amazon Web Services public cloud offering. And hybrid, basically becoming the reality, is basically private cloud and public cloud talking to each other. An example for that would be like a 9800 private cloud instance talking to a DNA Spaces in the public cloud, which will more likely start becoming reality in the future, wherein public and private cloud spaces are forming a hybrid cloud instance. So this is a high-level view of the cloud portfolio. Hypervisors supported for the private cloud are ESXi, KVM, NFVIS on ENCS. One of the key differentiators, if folks here are familiar with the AirOS brand of virtual wireless LAN controllers, that virtual wireless LAN controllers only offered FlexConnect mode. The private cloud offering of 9800 cloud basically mirrors whatever features appliance offers. That means all the modes of operation are supported, all the tools that are available in appliances are also available to the private cloud version. For the public cloud, only Amazon Web Services is supported for now with a managed VPN gateway setup in your branch deployments, 1,000 access points in a 10,000 client scale, and FlexConnect is the only mode, which makes sense because you do not want to bring all the data back into your cloud and bear the cost for that. All right, so from a private cloud standpoint, again, a little busy slide, let me just simplify it. It just shows that that private cloud can support both branch deployments and local mode deployments, basically signifying a key strategy change from where we were with the virtual wireless LAN controllers on AirOS, which only supported the branch deployment modes and also had like an uplink throughput limitation of about 500 Mbps, which is like very different from the 2.5 gigs what is offered on the private cloud appliances. And from an VMware ESXi standpoint, you have 3 modes of deployment, small, medium, or large. And if you look at the large, up to 6,000 access points, which is what your 9880, the highest end appliance, offers. So literally matching parity with your appliances within the hypervisor scale. And same thing for your KVM. Same OS experience, but different models available. All right, So public cloud, now it's actually a very, it becomes an interesting conversation when we talk about public cloud. Whenever we say public cloud and Cisco, there is a lot of questions on what is the difference between 9800 controller on public cloud versus that of Meraki. Anyone here had that question? What is the difference in public cloud offering? Right. So to understand the difference between a Meraki model versus a 9800 model, let's actually understand what public cloud offerings really mean. So there are three types of service model that are available for public cloud. So one is IaaS, or infrastructure as a service. So in infrastructure as a service, you basically rent out the bare metal network servers and firewall and storage from the cloud provider. In this case, vendor would be Amazon Web Services, and customer would be Cisco. And the customer, Cisco, would be in charge of building the operating system on top of that existing network server and the application on top of it, and then user registration on top of it. So there is a lot of work for the customer, and vendor will just provide the network. But in this case, you have more granularity and control of what you own in terms of operating system and application, and have higher efficiency. Then you have something called PaaS, or the platform as a service. Platform as a service, basically apart from the IaaS, it will now offer application services on top of the existing infrastructure. That means this will have an OS already built on top of the network server, and wherein the customer would, in this case Cisco, would just be in charge of just building the application on top of it. It will just be running application on top of application services. SaaS-based model, you already have the application installed, so everything is all you do is just log in, you have a registration, and all you do is just, take advantage of the services. So Meraki falls under the SaaS-based model of the public cloud deployment, and the Amazon Web Services-based 9800 falls under the IaaS model, or the infrastructure or as a service, wherein there is more granularity and control of how you basically program your operating system and the application on top of it, and you just take the bare metal servers from the Amazon Web Services. So that's the key difference. So key advantages of public cloud offering, basically you pay nothing for the controller on the cloud, you only bear the data cost on the Amazon Web Services. On a group survey, it took about 7 minutes to install 9800 control CL on the Amazon Web Services. But one of the key differentiators is this is the only public cloud controller offering today that is certified for AWS GovCloud, which is like a federally certified way of handling data, protected data for the government. So that's the key differentiator there. For a branch deployment, you would need a router and a managed VPN connection back into the Amazon Web Services to start getting your access points being managed by the Amazon Web Services-based 9800 public cloud offering. So this is the only mode that is supported. There are future modes that are coming in. And that's for the cloud offering. Let's understand the software-defined access, or the new network intuitive way Cisco is moving. For those who are interested in running the 9800 controller as a part or embedded inside the switch, the 9800 switch, the switch would need to be part of the fabric or part of the software and defined access network. That is the only method you would be able to enable wireless LAN controller functionality on a as embedded on a switch. And that switch, obviously, from a wireless functionality will be enabled by the DNA center once you're adding the switch as part of the DNA center. For the private appliance or so private cloud or the appliances, the feature functionality is exactly the same as what AirOS offers. So you can run it as part of Fabric. You can run it over the top if you don't want the wireless to be part of the Fabric, but you're wired to be in the Fabric network. You can run it just to take advantage of automation and assurance without running Fabric. So the private cloud and the appliances offer that benefit as AirOS. But if you are trying to run the controller on the embedded into the switch, you would need the switch to be part of the SD access or the Fabric strategy. So again, a busy slide. Let me just break it down for you. On the left-hand side for the software-defined access network is what you call a campus design. On the right-hand side is what you call a a branch design. Imagine that like a Flex Connect deployment. So for a campus design, for a fabric, you would need a co-located border or a control plane, followed by a fabric edge where your access points will terminate to. And for a branch design, let's say it's in a remote location and you don't want to bring your DNS center to a localized location, you can make the switch, the same switch like a 9300 or a 9400 switch, a border, control plane, and fabric all in the same box, and that concept is called fabric in a box. And all this PPT tries to denote is on the 1.2.10 version of the DNA and 16.10.1 version, what are the platform models that are supported. So 9300 is the only switch on 16.10 that would be supporting fabric in a box, which got upgraded to 9400, which can do both co-located border control plane and the fabric edge and a fabric in a box on 16.11 version. So starting 16.11, both 9300 and 9400 can be this fabric in a box setup. All right, so all this time what we heard was why we need Catalyst 9800 controllers, part of the intent-based networking strategy, and the intelligence features of that same operating system being deployed in an appliance, as part of cloud, as part of software-defined access. Now we entered my favorite feature, me coming from wireless tech. This resiliency is one of my favorite features because customers seldom call us for delivering good news. There's always something crashing, something bad happening, and we have to patch fix problem. And this 9800, the reason why I'm very excited is about giving least amount of pain to customers and end users in terms of network upgrade. So let's actually start with an interesting poll. There was actually a poll on how long can people survive without the internet. So the baseline was set to be 1990. That's because 1990 is when, before 1990, internet wasn't realizing at homes, and before the time till evolution, like till we were evolving, what would be the tolerance time before 1990 was 2 million years, because no one cared about network connectivity or internet. So 1990 till now, does anyone want to take a guess how much tolerance you have for internet, loss of network connectivity? How long can you survive without internet? Wow, that's a great. Break the ISP, get the phone call within 2 minutes. Okay, that's. All right, that's a great answer. So it's an evolved answer for that. So that basically turns down into how highly available your network can be, right? So a highly available network is defined by, or a reliable network is defined by 5-9 strategy. I don't know if anyone has heard about that. 5 nines is basically 99.999% available. And if you actually translate that 99.999% availability, that translates to about 5.26 minutes per year. So a good, highly available network should not go down for more than 5.26 minutes per year. Imagine our AirOS network today, when one reboot, and we would have consumed a year worth of outage time for a highly available network. So 9800 controllers is one of the true controllers that is actually trying to get close into this high availability strategy. So before I cover some of the scenarios and get into demonstrations, I want to explain what we'll be covering here. So when we talk about high availability, there is planned events and then there is unplanned events. What is unplanned events? Unplanned events is when your controller crashes, reboots, hangs, or there is like a general power outage, whatever, right? So those unplanned events are already being covered by what AirOS already offers. So you have HASSO or active standby failover scenarios, the stateful switchover, and then you have the N+1 primary and secondary, wherein you could have controllers in 2 different data centers, and then you have the AP primary tertiary. The AP is high availability. Nothing has changed in the unplanned event category from what AirOS already offers. So we will not be going into details on what unplanned, how 9800 covers the unplanned events. But what are planned network events? Why do you upgrade your controller? So you either want to, you upgrade your controller to either patch fix a problem, like you move from one maintenance release to another, to you patch fix a problem in your controller. a bug. You upgrade the controller for a PCert. You upgrade the controller because there is an AP problem, because you now need to push a package to the AP, or upgrade for the AP, or you upgrade the controller from one version to other to add a new feature, or to support a newer AP model. So those are the reasons why you need a planned maintenance upgrade event. How controller covers those is what we'll be going over one by one today. So you have, for any controller upgrade, imagine this like your maintenance upgrade. So from an iOS terminology, let's say you're upgrading from 85120 to 85150. You don't necessarily upgrade within the same branch because you actually want a different feature. You actually upgrade to actually fix bugs or PCerts. So we have something called software maintenance upgrade, SMUs, for controller updates on 9800. And all AP side fixes go under AP service pack. So AP bugs will go under AP service pack. And if you are trying to upgrade the functionality of the controller to introduce a new AP model support, we'll have AP device pack. Okay. So let's understand one by one, how do you tackle the controller? So let's say there's a bug in controller, how do you tackle that? So there's two methods, and people who are familiar with iOS XE Switch will already be familiar with these two terminologies: hot patching and cold patching. What is hot patch? Hot patch is, in my opinion, the best case scenario in the network, wherein you just have a patch fix and you can just upgrade the patch fix live in your network. There's no interruption or a requirement for a reload for wireless or access point or client, no interruptions. You just target one component and boom, it fixes the component. Cold patch. Cold patch is the traditional approach wherein you really require a reboot of the wireless controller because that component upgrade requires a restart of the services to take in effect. So how we just mentioned that 9800 tries to achieve zero client downtime during all the unplanned events scenarios. So how does cold patching create zero downtime? Because it requires a reboot. So let's understand that. So two types of network deployments. You have either a standalone box without any redundancy support, or you have a redundant box wherein you have a primary and a standby. Okay, so when you have a hot patch, which is the best case scenario, standalone box, you can install that patch, no outage event required. Same thing for redundant box. You install it on primary, it will percolate into secondary, and all this time no disruption. When you install a cold patch, the standalone box is the only scenario where you will require a reload, and by an efficient design, you will always add redundancy to your controller, either as an N+1 or as a redundant box. In a redundant box scenario, you will not experience an outage as a standalone box, because what we have something called in-service software upgrade or ISSU based SMU upgrade. How does that work? Let's say you have an active and a standby, and you have a maintenance patch. You upgrade that cold patch on via the active, and it will install the image on the standby, and the standby will go through a reload. All this time active is catering to your clients and your access points, and standby will reload, come back up with the SMU patch, and now you trigger the failover, and the secondary would be the new active, the primary would be the standby. All the clients and the APs would have already been absorbed by the secondary, which is the new active, by the AP and client SSO transitions. And now the new standby, which is the primary, will can reboot, and you can install the SMU patch. All this time, your network hasn't experienced a disruption, but you have upgraded your controller without actually causing a disruption. So a feature that is available in cold patch concept. So I'm going to quickly ask Alex to, all right, excellent. So this is a video of how hot patching works. This example is sharing is three clients that are connected, and you notice that there is no application visibility. The application visibility control is enabled on the WLAN, but there's no AVC stat showing for the clients. Okay, so it's empty. But when you click on the global application stats, the global application visibility is enabled. That means all the clients' cumulative stats are being shown, but individual client stats for application visibility is not shown. So this example is a clear bug, because this is a bug wherein the individual stats are not showing. And this example will show how do you basically upgrade controller without causing outage. So in this, you go to the administration software management. You already have in this case, we already have the SMU stored in the boot flash, or you can always import it from your desktop or TFTP that. And you see that all this time there is logs already shown in the right side. And right now the device is installed but inactive. For like any in iOS XE, you just need to activate for the fix to take effect. You click on that fix and you go ahead and activate that fix. And that is going to install, and all this time you will see the installation logs visible on the right-hand side. And it will be activating the maintenance. And if you notice, the controller screen hasn't reloaded, or the clients have not reloaded. And once the installation operation has happened, you basically, it takes a couple of seconds for it to activate, and you see a success log that it has activated. And now when you go back to the original clients, it will just take a few seconds and it will refresh the stats, and the stats which you didn't see for the individual clients is now visible, which basically means you have hot patched a network without actually creating an outage window. Is this not working? Okay. All right, so hopefully this mic is better in case someone had audio issues. You can fix it. But wireless network is not all about controllers. There are bugs inside the access points too. And access points, unfortunately, till today, are not hot patchable. That means when you install a patch fix on your 2800s or 3800s, you would need that access point to reload for that fix to take effect, right? So how does 9800 still offer a method to upgrade your AP image from the controller with causing least disruption as possible or zero network outage? So to understand that, let's actually understand what are the various upgrade options that are available. So starting the FCS release on 1610, there is a concept called rolling AP upgrade that is supported. And on 1611, we added something called AP device pack and flexible per site and per AP model upgrade. So what is rolling AP upgrade? This is a very important concept which will be used throughout, even on the controller upgrades and our future upgrades. So it's important to understand what rolling AP upgrade really means. So let's say rolling AP upgrade, let's say you have a network of about 100 access points, okay? Rolling AP upgrade is a process wherein you upgrade your site or the specific building in a staggered fashion without causing an entire access point outage. So let's say I choose 5 or 15 or 25% of the access points, and let's say I choose 5 per se, and there are 100 access points. What rolling AP upgrade is a process of upgrading 5 access points at a time in 20 iterations. But remember, those 5, who would choose those 5? No, not you, the user. The RRM would help choose the 5 access points that are best suitable at that particular time for a pre-download and upgrade, whilst its neighbors can cover that area during the temporary outage where this access point is going to go through a reload process. So it's not going to be 5 consecutive access points, it's going to be 5 access points handpicked by RRM to choose what will be the best upgrade scenarios there. So, once a batch of 5 gets upgraded and comes back up, it will start catering to the client, and the next 5 would get chosen until there are no more access points to upgrade and all are actually upgraded. And in this process, we have basically created an access point upgrade wherein you have literally trying to cause zero network downtime for your wireless clients. So so let's say I am connecting, sorry, yeah, go ahead, your question?
Question regarding when it comes to outdoor wireless.
Mm-hmm.
So if the access points are actually being bridged,
Mm-hmm.
in that circumstance,
Excellent question. So the question is, how does mesh network work for rolling up AP upgrade scenario? To be precise, mesh network will be impacted because there is because once you lose a root AP connection, the mesh already will be disrupted. So the process would, first of all, I don't think mesh is currently supported for rolling AP upgrade, but I think future plan there would be how you upgrade the maps first, and then upgrade the wrap, and as long as there is a suitable parent for the maps to like hand over to another wraps, I think RRM would make a decision in that direction. But rolling AP upgrade for now, I think, is only for the indoor access points. But a great question. It's something coming in the pipeline for the outdoor access point upgrades. Just to piggyback on what you said, when I am an access point, I predownloaded an image, and RRM has chosen me. Not always will I be client-free. I would be less loaded, and RRM would have chosen me. So when I reboot, the clients are going to go ahead and get an abrupt disassociation. How do we cover that scenario? So we have something called 802.11v as part of your 802.11r KV suites. So all the modern clients do this 802.11v, which is called a BSS transitioning request, where the access points will say, hey, the client associated to me, I'm going to go through a reboot, so a disassociation is imminent for you. Go ahead and steer yourself into this BSS ID, my neighbor, and that 802.11v, as long as that client can understand 802.11v, it will steer itself into that portfolio whilst without creating a hard roaming scenario for the client. That's still not a disassociation, even if it's a hard roaming, but this is a more elegant way of transitioning. So this concept will be, we'll keep on reusing this concept into multiple other techniques. So on 16.11, we introduced something called per site per AP model AP service pack. What is that? So now you can focus your upgrade, and now not always does all the bug fixes apply to every access point. So for example, if you have a mixed match of 2800s and 3700s, which is based on AP COS and AP iOS respectively, you don't have to upgrade the entire network infrastructure for fixing bug on a specific AP platform. Now you can target the specific AP platform that are involved in the upgrade process without impacting other access point that are simply have nothing to do with that upgrade. How does that work? So let's understand that with an example. So there are 3 sites here: Site A, Site B, and Site C. Site A has 2800s and 3800 access points in 2 buildings. Site B has 9115s and the 3800 access points, and the Site C has 2800 access points. And let's assume that there is a bug on which is only impacting the 2800s and 3800 models and not any other model. So you install the per site AP service pack, and the 9800 is intelligent enough to understand that on site A, the fix is applicable for both the buildings because it has 2800s and 3800s. So it will start the rolling AP upgrade on a per site fashion, wherein it will patch fix in a rolling AP upgrade fashion without causing an entire outage. In a batched fashion, it will complete the fix as long as all the access points are now completely fixed without actually disrupting site B or site C. Now, once site A is complete, you can start the same process in site B. Site B 9800 will now realize that 9115 access points in building 1 is not impacted, so it will just patch fix the building 2 on the 3800 access points until all is complete. Any questions on AP service pack, how it works? And then AP device pack. Now, this is also a very interesting feature. We all know that we upgrade controllers a lot to support a new AP model, and that is a huge disruption within the network infrastructure. Rather than understanding how this workflow works, I'd rather give a demo on how this is working. All right, in this example, you have a controller CLI on 16.10.1 code. And 16.10.1, for folks who don't realize, it doesn't support the latest Wi-Fi 6 access points. To support the Wi-Fi 6 or the 9100 access points, you need the 16.11 code. So ideally, this would be the scenario wherein you would need to upgrade your controller from 16.10 to 16.11, but not in this case. What we are showing is some of the SSIDs that are being broadcasted there, and a client in this machine is actually connected to that SSID, And we are running a ping test to show that all this time during the upgrade, there is no network disruption. So on the show install summary, we basically see that the AP device pack is not installed. So we'll get the AP device pack from the boot flash and go ahead and install that AP device pack, which adds the capability to support 9100 access points within this controller. So there will be, as you can see, the install add command is complete. And if you remember from the SMU demo, just adding the file is not enough. We have to activate the file for the fix to take effect. As you can see in the logs, we still see that the access point is not supported and it's not able to join. So the next step here would be to activate that installed file, which you can see from the show install summary would not be activated. Okay, so in this example, you see the user has activated install activate file, and it takes a few seconds for it to complete. And once it's complete, installed successfully, the show install summary will put it in a U state. It'll which basically means it's installed but uncommitted. It will go into a committed state once an access point initiates a discovery request into the controller. So now you can see that the fix is ready. On a 1610 platform, we are basically going to add, you see that the 9117 access points is actually started downloading the code because you hot patched an AP device pack fix into a controller that doesn't support this version. Any questions? Sure. So great question. The question, if anyone wasn't able to hear, how do you understand which AP model the service pack is applicable for? 9800 makes that decision because it will absorb that service pack, and 9800 will automatically tell you understand based on the image file that is uploaded, APG1 or APG3, whichever uses that base code model, it will go ahead and apply to that specific model. So 9800 understands which AP is using that specific base code and will install it to those access points with that base code. All right, so that was for the, yeah, go ahead.
Sorry, I don't know if you answered this, but can you pick the part of the buildings where you want the upgrades to first roll out and then?
Correct. That's the so the question is, can you pick a specific site for upgrade before going through an upgrade to an entire network infrastructure? Yes, that's the entire purpose of the per site network update. If I can go back a few slides. This is the per site workflow wherein you install just on site A. This is part of the same network, but site A, site B, site C, you can choose which you want to upgrade first from by adding that filter, add site A only. So that was the new feature that got added into the latest 1611 version. Great question. All right, so to recap, what we understood so far is how do you hot patch or cold patch a controller if you have a bug or a problem in a controller? How do you hot patch or AP service pack or AP device pack from an AP perspective? Now, let's address the elephant in the room. How do you upgrade controllers from one version to another? Because that really requires a reload. So now all this time we were just understanding patching the controllers and access points. How do you go from one version, so 1610 to 1611, 1611 to 1612, 1612 to 17.1? How do you go about doing that? So we'll go over that in a bit right now. So you have something, two methods, N+1 rolling upgrade and an ISSU upgrade, which hasn't released yet, but I'll show a brief preview of what is that all about. So N+1 rolling upgrade. What is this all about? So in N+1 rolling AP upgrade, what you need is a primary and an N+1 in a same mobility group. So in this case, you are going to upgrade the primary, which is in version X, and you are going to upgrade it to the desired version X+1. Now the requirement here is that the N+1 controller in your network already is upgraded to the required X+1 version. Okay, so what you do is you trigger the N+1 rolling AP upgrade from the primary, and it will install the image on the primary, and it will go ahead and start the rolling AP upgrade process into the access points in the primary. So what is rolling AP upgrade? We basically choose a percentage of access points in the deployment that need to be pre-downloaded the code, and that AP will go through an upgrade. So except in this case, after going through the pre-download, it will now be sent to the N+1 controller, and after the batches will be sent to the N+1 controller while the other access points are still catering to the client. And as long as the configuration is matching on the N+1 controller, these access points are going to go there, join that reload, and start catering to the client in a salt and pepper fashion until all the access points are pre-downloaded and upgraded and move into the N+1. Now, which makes a primary, which is access point free, and you can basically just reload that, create the upgrade, and then access point will move in a batched fashion with the regular high availability into the primary controller. And you have basically upgraded your controller in an N+1 fashion, all with just one click. And as long as they're in the same mobility group, all with just one click, you have just completed this process and caused literally zero downtime for your clients in a salt and pepper design. Any questions? All right. Starting this feature, the ISSU based upgrade or the in-service software upgrade, this is my personal favorite. It hasn't released yet. It's going to come up in the 16.12.3 or the 17.1 versions. Let's say you don't have an N+1 device, you have a HA pair, like a primary and a secondary. So your active and standby are in V1, and your access points joined to the active will be in V1. Okay. Now let's understand how you upgrade a HA pair without actually causing a network outage from one version to another. So active in V1 and standby in V1. So you basically initiate an ISSU upgrade in your active, and you're going to V2. And what active will do is it will install the image and basically sync that image into standby. And at the same time, it will go ahead and upgrade or pre-download all the AP image into the access point in V1. All this time it's fine because all you're doing is syncing the image to standby and access points in V1. The next step, wherein you reload the standby, what will happen when you reload standby in a different version? And an active is on version 1 and standby is on version 2. Regular understanding on HA is both primary and secondary need to be in the same version. Otherwise, the HA won't sync. Not anymore. So standby on V2 will still sync with active in V1 for the ISSU upgrade process till the time the ISSU process is complete. So now the V1, which is active V1, which is still catering to access points V1, which has already pre-downloaded the code, now the standby has come back up and it is going to sync with the active in V1. And now the process will initiate a switchover on active. So what will happen? Access points will go into the standby in V2. But standby is in V2 and access point is still in V1. You need a reload on the access point for the access point to be on V2. Not anymore. The active V2 would still cater to access points in V1 till a point that the rolling AP upgrade is completed on the access point in a batched fashion till all the access points have come back up in a batched fashion. And at that time, till that time, access points in version 1 will be managed by a controller in version 2. So these are two fundamentally mind-blowing things that have happened on this ISSU-based upgrade. HA pair is basically syncing on two different versions, and a controller is managing API temporarily on another version. So something that is upcoming. And I have a demo for this, but I have to see if our time permits today on allowing that. Looks like it won't. I have like probably 10 more minutes to wrap up. Okay, security. All right, security, I'm going to just breeze through the slides because I want to get to the newer configuration model. Security from an over-the-air standpoint, the rogue detection and mitigation techniques of what adaptive whips offered on AirOS exactly mirror. Then you have the WPA3 support. From a device standpoint, you have encrypted threat analytics and identity PSK support. And from user standpoint, BYOD with ICE and automated micro and macro segmentation with STA. Again, these are just topics that require its own session. I'm not going to go into, and another beast of a topic, which I am not covering in details. I hope some of you were able to attend Jeremy's session yesterday. If not, I'd highly recommend a programmability telemetry session on 9800 via content catalog. Did you have a question? All right. So programmability telemetry on a high level is not only about automation and assurance by DNA Center. 9800 controllers operates basically has a netconf protocol. For folks not familiar, it's just SSH on port 830. And it can do standards-based interoperability, or it's available for model-driven programmability. It has something called Yang models, with which you can just, anything you can do via CLI or GUI in a 9800 controller, you can program that via the Yang models. Whether it's a show command or a config command, you will have that access. 9800 actually has a guest shell, Python shell in it. So for any coders, it's just a coder's paradise. I mean, you can just inbuilt write your own Python scripts within the guest shell and get stuff automated within the platform. And that's why this is a topic in itself that deserves a session. And I'm not going to go into too much details with due respect to that session. All right. For folks who raised your hands for familiarity with AirOS configuration model, I basically wanted to take some time explaining what is this newer configuration model that we're talking about. So for AirOS basically has 4 fundamental pillars. And majority might recognize this. There is a WLAN pillar, which has your basic and advanced wireless setting. You do your wireless security there. You also do your QoS policies there. You do your switching policies there. And then you have something called AP groups. AP groups is basically bunching the access points in a logical group, placing a building together or a site together. FlexConnect group, you can call it as an equivalent of an AP group in a branch deployment, wherein you're grouping the access point in a branch together. And RF profiles, which basically define the site-specific RF properties or the AP-specific RF properties for that site. If you notice this model, there's actually an unnecessary dependency between these 2 pillars. I don't know how many have noticed, but in case you have an RF profile tagged into AP groups or Flex groups, to make or add edit changes into RF profile, you would need to basically remove that dependency from an AP group or an Flex group. And there's this unnecessary dependency. But in reality, RF properties of an access point should have nothing to do with the broadcast domain of the access point or what I'm going to do with the security or the site-specific properties. So when our developers had a clean canvas to build a new configuration model, they decided to decouple and modularize some of these concepts so that they added only the relevant pieces to a bucket and started putting them as tags. So every access point now will basically be known via 3 tags: a policy tag, a site tag, and an RF tag. A policy tag on a high level basically defines the broadcast domain of that access point. So policy tag consists of a WLAN profile and a policy profile. Your WLAN profile is core wireless. What is the basic wireless setting? What is the advanced wireless? And what is your wireless security? Policy profile is what is your policy? What is your QoS policy? What is your switching policy? And you add that and you tag it to a policy tag. That will be a unique identifying factor for the access point. And then you have a site tag that defines the site-specific properties of the access points, which is nothing but what should my access points primary, secondary, tertiary be? What should my AP mode be, whether it's a local mode or FlexConnect mode? What should be my AP user credentials, whether I should use Telnet or SSH? All that AP-specific properties for that specific site, you push them as site tags. And then you have RF tag, which is exactly the RF profile mirror, except it's completely independent, no more tagged to the other buckets. And all the power basically goes to the access point. Every access point in the 9800 controller is going to be uniquely identified by these 3 tags. Another view basically would be policy tag, RF tag, and site tag powering the access point. policy tag defining the broadcast domain, site tag defining the site-specific properties, and RF tag determining the RF properties of the network. So it is recommended that you have every access point that joins a 9800 controller basically goes into the default site tag. And it is recommended that you create a location for every access point so that, and every site tag basically supports up to 400 access points. So there are several questions that get asked on what happens when I have more than 400 access points within the same site. You basically divide that site in a logical way that you have 400 access points in one site and 400 into other. So in that example, you basically split the building in a logical fashion wherein you divide the site tags in 400. Roaming will work across site tags. And then you have two, what if you have two buildings, each have 400? Well and good, then split it by the building and put them in two different site tags. What if you have two buildings, combined capacity is 400 access points. Okay, just put them under one site tag. But make sure that it is under 400 access points and you do not use the default site tag for any new AP additions and all that stuff. All right, so 9800 adoption. Let me, how much time do I have? I have 4 minutes, which exactly means I don't have time for a quick demonstration. So migration-wise, I don't know how many have seen this tool. You have a cloud tool called Wireless Config Converter, and you also have something called a config translator inside your 9800 GUI itself. So let me actually show that. That's actually worth showing. Just give me a couple of seconds, guys. This is my Lab 9800 controller, so. So this is the GUI of a 16.12.1 controller. You have, and if you go to configuration, you see something called AeroOS config translator. You can go here and upload your AeroOS configuration file. All right, I have a sample AeroOS configuration file. Hopefully that's a valid configuration file. And boom, yeah. So it translated your AeroOS configuration. About 80% of the configuration got translated. And the cool thing is you can just apply the configuration right there from an AeroOS. So for there is also unsupported, which basically is not supported on the 9800 from an AeroOS configuration, and an unmapped, which basically means it doesn't, that feature doesn't exist or is not relevant to the 9800 controller. So you can have a look at those CLIs too. From that specific point. So that's the power of migration. You can do it in a cloud way too, but if you don't have a controller setup, you can do that too. There actually is a lab Alex and I are running tomorrow. It's a hands-on solutions lab. I did see a few slots still available. It was full, but I think there's a couple of slots. If you do want to get a hands-on, it's a 2-hour lab. You'll be able to set up 9800 from scratch, join AP, even go to DNA Center, join it with ICE. Lot of cool stuff happening in that. All right. So there actually also is a best practice menu. So for those who are not wireless experts and just want your configuration review, you already have that within the tool. And then I have a last minute. I'm just going to quickly cover how do you integrate 9800 controller with your existing AeroOS deployments. You have something called a secure CapWap mobility, which you require for joining a 9800 controller to a mobility group with AeroOS controllers. And your AeroOS needs to be on the 88120 code, or if you have a 5508 controller that doesn't go to the 8.8 code, you would need a 85 MR5 IRCM, or the inter-release controller mobility release. And the cool thing about this, as compared to the the new mobility feature we had with converged access is that the secure CAPAP mobility can still work fine with existing AirOS deployments, wherein your regular EUIP mobility will still be functioning, and you can have a secure CAPAP mobility for the controllers on supported version. So there is no this or that approach. It is basically a combined approach. And the roaming is layer 3 only, which means roam 2 controllers will, the clients will, IP will anchor back to the roam 2 controller. And if you're doing a guest anchoring, you can basically and have multiple controllers. Recommend to use the AirOS with the 88MR120 code so that it can be anchored to both 9800 via the secure mobility and AirOS. If you just have a 9800 and AirOS, both modes are supported. 9800 can be its anchor itself. And with that, I'm done with the presentation. Thank you for bearing this fast-paced presentation, because I had to consolidate a lot of content within 60 minutes. So I absolutely appreciate your feedback. I hope you liked some of the demonstrations. I wish I could have shown more. It's really cool, but definitely do spend some time. If you do have some time, come to our lab tomorrow, and it's a 2-hour lab, and you would get hands-on on some of these topics, and added some few reference guides for you. And thank you. Please feel free to complete our evaluation service, and that's how we improve. Right? Thanks, guys.